Okay, let's have a look at these questions then. Right, the first one is, what fraction of a circle is 120 degrees? Now, this is a question that requires us to understand firstly what degrees are and how many of them might be inside a circle. So we're just going to go on a little diversion here, and let's have a look at this here. Right, we have here a circle. All right, we'll look at this picture first. Let me just put my proper pen on. Okay, so we're going to have a look at this picture first, and if you can imagine, if we had a string attached to a pin or something. All right, so we have a string. Let's imagine that this is the string, and we're going to attach it to a thumbtack or a pin, and we push that right in the middle of a circle. Okay, so we've got this fixed point here. This isn't going to move, and we've got this piece of string, and we're going to keep it really tight, this string. Okay, we can imagine it's something that's quite stiff and rigid that can't bend or anything, or we keep it tight. And we start to move the string round. We start to rotate it, okay, around this fixed point. Okay, so we imagine we're moving the string, Imagine this string has now got to here. What we are talking about with degrees is a way of measuring how far we have moved around. Okay, when we have, so here we've got a string. If we move this string all the way around to here, all right, this point has remained fixed. Our string is here. Can you see we have now traveled 1/4 of the way around the circle? If we keep traveling around, let's keep moving our string, keep moving our string, keep moving our string. This is now halfway round our circle. If we kept our string moving around to here, that would be 3/4 of the way round, and if we kept on going all the way around to the top, we would have completed one complete turn. Okay, and we need some way of measuring how far this is, what this represents, what part of a turn we have moved. So if we go and have a look at this circle, can you see all of these little divisions here? Someone's taken a complete circle. All right, we're going to imagine our line again. Okay, and this isn't going to look very good, but imagine that was a straight line, and imagine this is again our fixed point, and we're moving this string all the way around. This circle has been subdivided into 360 perfectly equal divisions. Okay, and we call each of these a degree, 1 degree. It says here we use units called degrees to precisely describe an amount of turn. All right, and this is how we measure the size of an angle. And the symbols for degrees is this small circle there. Okay, so a full turn, all right, if we went round the whole circle, that would be 360 degrees. So there are 360 degrees in a circle, or one full turn. All right, and each one of these little sections is the same as 1/360. Okay, because there are 360 equal size parts in this one circle, this one turn. Okay, this bit here that's been shaded orange, that represents 100 degrees, which would be 100 out of 360 degrees. Okay, this section here, okay, that shows 10 degrees. All right, this one here shows 1 degree. Okay, so hopefully that's a little bit of revision that explains what a degree is, and a reminder that there are 360 degrees in a circle. Right, I'm going to rub that out and go back, hopefully. Oh, I need to do this, go back to the question. Fantastic, right. Okay, So what are we asked? We are asked what fraction of a circle is 120 degrees. Okay, so we need to remember that a circle has how many? 360 degrees. Okay, so a circle has 360 degrees, and this is something you should understand and then know off by heart. So it should be something that you know. That's 360 degrees, and we've got 120 of them. Okay, so as it stands, this is a fraction, 120 over 360. Okay, but what do we do to fractions? Well, we like to simplify them. Okay, and the first thing I'm actually going to do is I'm going to divide both the top and the bottom by 10. All right, so I'm going to do that, and that's the same as if so 120 divided by 10 is 12. 360 divided by 10 is 36. So actually I'm just going to do that there. Okay, so I've now got 12 over 36. Now, is this looking familiar? Is there anything we need to think? What's the biggest number that we can divide into both top and bottom? And hopefully you should be able to recognize that 12 times 3 is 36. So I must be able to, I can divide both top and bottom by 12. I'm going to divide this by 12. I'm going to divide this by 12. All right, if I multiply or divide both the top and the bottom of a fraction by the same number, it will give me an equivalent fraction. That means a fraction that looks different but has the same value. All right, so 12 divided by 12 is 1. Okay, and 36 divided by 12 is 3. Okay, so 12 over 36, or indeed 120 over 360, is the same as 1 over 3, or 1/3. Okay, so that's that answer there, 1/3. Okay, let's have a look at the next question. I'm just going to get rid of this bit. Okay, so it says add 2/3 of 12 to 3/8 of 16. Okay, so we can do these in two ways. If you can choose to do a multiplication of fractions, because we know that 2/3 of 12 is the same as 2/3 times 12. Okay, so that would be 2 over 3 times 12 over 1. All right, because 12 is the same as 12 over 1. And then add that to 3/8 of 16. But the way most children at this point will normally do it is to think, okay, what's 2/3 of 12? I want 2/3 of 12. Well, what is 1/3 of 12? What's 1/3 of 12? Okay, well, to find 1/3 of 12, I need to divide 12 by 3, which gives me 4. So 1/3 of 12 is 4. Okay, so 2/3 of 12 must be 4 times 2, which is 8. All right, so 2/3 of 12 is 8. Okay, right, so that's the first bit. So that's add 2/3 of 12, so I've got that, that's 8. All right, to 3/8 of 16, so I want 3/8 of 16. Okay, well, if I want to find out 1/8 of 16, I need to divide 16 by 8. So 1/8 of 16, 16 divided by 8. What does that give us? That gives us 2. Okay, and then so 1/8 of 16 is 2. What's 3/8 of 16? Well, that must be 2 times 3, which gives us 6. Okay, so this bit is 6, and we've been asked to add these two amounts together. So 8 add 6. All right, so 8 add 2 is 10, plus the remaining 4 gives us 14. Okay, so that's just the answer there. It's not any units or anything. Okay, let's have a look at the next one. What fraction of 1 hour is 24 minutes? Okay, so we have to think, so fractions, we're talking about parts of something. We have 24 minutes. Well, how many minutes are there in a whole hour? So oh, why isn't that working? I've upset it. In fact, I'll just rub this bit out. Put that back on. So 1 hour equals 60 minutes. Okay, and we're asked what fraction of 1 hour is 24 minutes. So, well, what we're talking about then is 24 minutes out of 60 minutes. So that's the fraction that we have, and it's always implied that we want to simplify this as far as possible. Okay, and so we have to think of the biggest number that will divide in both top and bottom, and I think that's going to be 12. All right, I know that 12 goes into 24, and I also know that 12 goes into 60. So I'm going to divide both top and bottom by 12. So divide by 12, divide by 12, and if I divide both the numerator and the denominator of a fraction by the same number, I'm going to get a fraction that looks different but has the same value. It's an equivalent, an equal value fraction. Okay, so what am I going to get? So 24 divided by 12 is 2, okay, and 60 divided by 12 is 5. Okay, there's 5 12s in 60. 12 times 5 is 60. So that gives me 2/5. Okay, so 2/5 for that one. Okay, let's have a look at this next question here. An 800 milliliter bottle is 3/4 full. How many milliliters does it contain? Okay, so 800 milliliter bottle, that's the whole amount. All right, that's the whole amount. And at the moment it's 3/4 full. So I want to find out, firstly, it would help me to find out what is 1/4 of 800 milliliters. Okay, so what's 1/4 of 800? Well, I need to divide the 800 by 4. Okay, so how many 4s go into 8? Well, that's 2. So 1/4 equals 200. All right, 200 milliliters in this case. All right, and I'm asked what 3/4 is. Sorry, and that would be 3 times 1/4. Okay, 3/4 is the same as 3 times 1/4. So 3/4 is 200 milliliters times 3, which gives us 600 milliliters. Okay, so this answer is 600. All right, okay, and I'm just going to give myself some room here, and we'll look at this last question here. A fifth of a sum of money. Okay, this is going to be an interesting one. A fifth of a sum of money is £3.50. And how much is the full amount? Now, for me, this is the perfect question to use what we call bar models, or, I mean, don't even worry about what the name of them is, but to try and visualize, try and draw some kind of diagram to visualize what is going on. So what is 1/5 of an amount? Well, 1/5 is as if so let's say that's 1, 2, 3, 4, 5. Okay, so imagine that this whole bar here represents this whole amount, the full amount. This is the full amount. Okay, and it is divided into 1, 2, 3, 4, 5 equal size portions. They might not look very equal, but they're equal enough. Okay, so these represent, so this is equal to this, is equal to this, equal to this, is equal to this. Okay, so this, okay, one of these is equal to 1/5. Okay, and we are told that a fifth, that's the same as, so a fifth is 1/5. Okay, a fifth, 1/5 of a sum of money is £3.50. So this is £3.50. Okay, so one of these is £3.50, and we want to know what this whole amount is. Okay, so if this is £3.50, then this must also be £3.50, and this is £3.50, as is this, as is this. Okay, and what we could do is we could add all of these up if we wanted. So we could do a big long calculations of 5 £3.50s, or what we normally do when we are doing repeated addition of the same number is we do a multiplication. Okay, and that's what's implied by saying 1/5 anyway. So I've got 1/5, I want to know what is, so if 1/5 equals £3.50, what is 5/5? Yes, that's the question. What's the whole? All right, 5/5 represents the whole thing. So we're then going to do 3.5. All right, we don't actually need the 0. Okay, so 3.5, and we're going to multiply that by 5. Okay, so what's 5 times 5? 25. I'll be good and put that down there. I normally put mine up there, but there we go. And then we've got 3 5s are 15, and then we've got to add on the 20 that we had left here. So 3 times 5 is 15, 16, 17, 18. Sorry, what am I doing? 15, 16, 17. All right, 3 times 5 is 15, plus 2 is 17. Okay, I'm thinking an adult brain, far too much chocolate over Easter. There we go. All right, and that gives us 17.5. All right, so the whole amount must be 17.5. All right, and if you decided to add up, you know, put £3.50, £3.50, £3.50, £3.50, £3.50, you would get 17.5. So, oh right, that's interesting. There we go. It's decided to go giant. Right, 17.5. Okay. Hopefully I didn't befuddle you here. And hopefully you now understand how to approach a question like this. If you're not sure, then it's always really good to draw a diagram to represent what you think is going on, and that hopefully makes it clearer to see what calculation you have to do. I hope that helps.